Today we're going to solve for unknown angles and work with some definitions, angles and lines, and look at angles and lines at a point. So to start with some definitions, two angles, angle AOC, two angles AOC and COB with a common side, OC, we can call those adjacent. They are adjacent if C belongs to the interior of AOB. So here's what that looks like. If I have AOC and COB, that means my vertex is at O, and I have, this is O, and this would be AOC and COB. If C is in the interior of angle AOB, they are adjacent. And then we have another definition. The sum of angles on a straight line is 180, so angles on a line add to 180. And two such angles are called a linear pair. All right, the next one, two angles are supplementary if the sum of their measure is 180 degrees. This should all be review. But please make sure you don't confuse supplementary and complementary. Two angles are called complementary if the sum of their measures is 90 degrees. We use supplementary usually a bit more than complementary. Now, describing angles as supplementary or complementary refers only to the measure of their angles, only to the measure. The positions of the angles, or whether the pair of angles is adjacent, is not part of the definition. So angles can be supplementary and not connected. If this is 120 degrees, and this is angle A, and this one is 60 degrees, and that's angle B, we could still say that angle A and angle B are supplementary, even though they are not connected. So we're going to use those definitions to solve for unknown angles. In our first example, we have line segment AB. Oh, it shouldn't be AB. That should be AD. Line segment AD is drawn. AD with a bar over it. That's the correct way. Line segment AD is drawn. And we want to find the measure of angle DCE. So we're trying to find this measure here. Well, we have to work with what's given now. It looks a little blurry on here, so this, let me just tell you, this is 72 degrees. So angle ACB is 72 degrees. And then the symbol in here implies that angle BCE is 90 degrees. So I'm going to write that in there. This is 90 degrees. All right, so what we know is that the sum of the angles on a line, because we're going to justify our answer, the sum of the angles on a line adds to 180. We can't say it's a linear pair because we have more than two angles here, but they add to 180. So if this is going to be x, then we know that x plus 72 plus 90 is equal to 180. So when you subtract the 72 and the 90, you end up with x is 18. Double checking, that's what we want. So the measure of DCE is 18 degrees. And our justification is the fact that the sum of the angles on a line equal 180. Okay, the second example, the total measure, this is something else we need to know. The total measure of adjacent angles around a point. Angles around a point add to 360 degrees. That's going to show up quite a bit this year. 360. And we want to find the measure of HKI. HKI is here, and if you can't see it, this is 133 degrees, and this is 147 degrees. So, because of this reason, the total measure, the angles around a point, add to 360, we can say that x plus 133 plus 147 is equal to 360 degrees. Subtracting 147 and 133 from 360, we get that x is going to be 80 degrees, so the measure of angle HKI is 80 degrees. The next justification that we will be using quite a bit this year has to do with vertical angles. Now, vertical angles are the angles that are across from each other when you have intersecting lines. So we have two sets of vertical angles. We have angle SRU and TRV. Those are vertical angles. Then we also have SRT and URV. These are also vertical angles. So vertical angles have equal measure. We'll also say later that vertical angles are congruent, but we're talking about measurements today, so we'll say equal measure. And we want to find the measure of angle TRV. Well, there's really no math to do. If I looked at this, since vertical angles have equal measure, the measure of angle TRV is 52 degrees. If I can write that right. Now, what if I wanted to find the measure of angle TRS? Well, if this is 52, you could, TRS and SRV are a linear pair. And linear pairs add to 180. There's my justification. Linear pairs add to 180 degrees. So there you could say the measure of angle TRS plus 52 degrees is equal to 180, and that would give the measure of angle TRS to be 128. So if you have one angle measurement in a pair of intersecting lines, you can find all four through vertical angles and through linear pairs. Finally, we're going to find angle measures and list out the reasons for each item. And then we'll practice all of this in class, because in Common Core it's not enough to find the mathematical answer. We have to justify our steps and list the reasons for why we are doing things. So the first one, angle A. Angle A, to find angle A and 145 form a linear pair. And linear pairs add to 180. So linear pairs add to 180 degrees. So if you take that and you subtract 180 from 145, you're going to end up with 35 degrees. Okay, the second one, angle B, if we look at this diagram. This is a set of intersecting lines, so we have vertical angles, and again we have linear pairs. So to start with B, linear pairs add to 180. Same reason, linear pairs add to 180. So by subtracting 40 from 180, we end up with 140 degrees. Once you have those two, we can easily find angle C and angle D, because C is vertical to 40 and D is vertical to B. So the measure of angle C has to be 40 degrees. The reason being is that vertical angles are equal in measure. We could also say they are congruent, but we'll say equal in measure today. Same thing with D. D is vertical to B, so D is 140 degrees. Same reason, vertical angles are equal in measure. Okay, now the last one uses the third reason that we've talked about. If this is 122 degrees and we want to find angle E sweeps from the back of 122 all the way around to the other side. So this angle here is irrelevant right now. We want to find angle E, which is everything but the 122. So to get that, we use the statement angles at a point, angles around a point, add to 360 degrees. And that's the justification. You're going to take 360, you're going to subtract 122, and you end up with 238 degrees. So this is a basic list of the justifications we're going to start using when we solve for unknown angles in class. Again, it's not enough just to find the mathematical answer. We have to justify our steps.